Um, Welcome. My name is Jay Pipes. I am a little Drizzle code monkey, so can you. I work on the Drizzle project, which is something new. About October last year, I started working on it. Brian started working on Drizzle about April last year. It's a fork of MySQL 6.0, and we're very heavily focused on community work. Community contributions and that kind of thing. We're targeting scalability over raw performance, which I'll get into in this talk. There's a few of our values as a community, which I'm going to talk about today, and you may not understand exactly what they have anything to do with performance until I tell you about them in the slides. So, one of the things that we're committed to is, sorry, this is really awkward. So one of the things that we're really committed to is open and public discourse about pretty much everything. So if we've got performance benchmarks that we've run, we want them to be peer reviewed in the open source community. But not just benchmarks, I'm talking about problems. If we've got problems in the source code, we want it to be open and public. We want people to come and review the code, take a look at it, give us ideas, contribute. So no more secrets, no more hiding. Let's get the benchmarks out there. Let's get our methodology out there. Let's open up as a community. So that's one of our values. Then focusing on the interface as opposed to the implementation. One of the things that we kind of acknowledge or recognize in Drizzle is that there is no one right way of doing something. If you have one implementation that works really well for one problem domain, that doesn't necessarily mean that it's going to work really well or be very performant for some other problem domain. And so what we're trying to focus on is making the interfaces between the core kernel and the outside plugin ecosystem as clean and as simple and as well documented as possible, so that folks like Paul McCullough or Mark Callahan from Google, they can implement the modules to perform best for their specific application domain. So we're not trying to tie one implementation to an interface within the kernel. We're trying to separate that out cleanly. Saying no to magic. So what I mean by this is magic code to me is something that really only one or two people understand. It's kind of littered all over the place in MySQL, and I'll talk a little bit about it in a few slides. It impacts performance because no one understands what the heck it does. When you have that situation, that means fewer developers can actually approach the code. It means fewer people can actually get involved and work on performance tuning. If they don't understand what's going on in the code, or it's just like this weird magic stuff that's going on, very few people can get involved. And so we want to break that boundary, remove that barrier for people. Using standard open source libraries is another big thing for us. Let the compiler and the library developers do their job. They're experts at what they do. So I don't want to be an expert at UTF-8. I don't know if you do either, but I prefer a library developer who knows their stuff, an expert on UTF-8 stuff, to do their library stuff. So I want to use open source standard libraries for that kind of thing. And then no new global contention points. That's one of our big things. So no new global mutexes. I don't know if anyone saw a blog post from Mark Callahan recently complaining about this, but this is one thing that we've absolutely said. Not only are we removing the global mutexes where we can, and using other strategies like RCU or atomics to overcome some of the scalability issues, but we're just absolutely no more global mutexes added to the core kernel. So these things I'll get into in a second. So open and public discourse. Benchmarks, published online and peer reviewed, right? We all, and I'm not into bashing MySQL or comparing Drizzle against MySQL. What I want to focus on here is we all got surprised on, what it was, Monday or Tuesday when they announced MySQL 5.4 with performance improvements. How cool would it have been if that stuff was kind of open to the public and we could all give our input as to the progress that was going on. One thing that we're striving for in Drizzle is all those benchmarks and the methodologies. We want to document it on the wiki. We want to get people coming in and saying, hey, have you thought about this? Maybe you're getting contention here because of this. So just opening that stuff up to a public discourse is important to us. There's no shame, there's no hiding, and there's no secrets in Drizzle. You know, everything out there, just get it out there. Don't be afraid of it. So here's kind of like a really simple, stupid graph, but it kind of shows you what we're focused on. And what you'll see in the middle, that's really what Drizzle is, right? The kernel, the core services. So we view the Drizzle server as a provider of services. We provide those services through a plugin API. I'll talk about Google Protobuffer messages in just a bit, but the plugin API is what allows module developers to communicate with the kernel, but we expect features to be written in the external module ecosystem. So what we've done mostly is remove features and clean the code up in the server. We went, I think MySQL 6.011 has 1.3 million lines of code. And remember, we're a fork of MySQL 6.0. We have 115,000 lines of code in the kernel. So it's a huge amount of code that's, we're trying to get as small as possible. Only deal with the most basic elements of the server in the kernel and let the features develop in the plugin ecosystem, the way that plugin developers want to develop them. So I've listed on the outside some of the plugins, or at least skeleton plugins or prototype plugins that already exist for Drizzle. So we've got sort of replication API, logging plugins, authentication, like you can technically authenticate with LDAP for Drizzle. But because we've removed the ACL and the grant system and the MySQL system database from Drizzle, and we push that stuff out into the plugin ecosystem. Because by having, for instance, the MySQL grants table, the show grants, all that stuff, well, what that does is it ties an implementation of an ACL into the core kernel. Well, what if it's better for, someone to use LDAP or use Active Directory for certain authentication stuff? Or they want to do RBAC authorization or role-based access control. If once you put the implementation inside the kernel, then you're locking it. So we say, push that stuff out into the module world and let people develop their own ways of doing authentication, authorization, that kind of thing. Does that make sense? Okay. Or the MySQL replication protocol. Well, here's our stand is, you guys are going to be creating these modules. And when I say you guys, I mean that. You may not be a C, C++ developer. I mean, our modules are going to be written in Python, Java, C, C++, Erlang, whatever you want, because of the way that the Google Protobuffer messages work, and I'll explain that in a second. But you guys are going to be the ones developing the modules. So we want your input on how this interface should be, right? And we want it to be an open and active debate on the public mailing lists, because you guys are going to be the ones that are using the interface, okay? So again, open and public. So the interface, when I say an interface, what is it? It's the kernel, right, sitting there and providing these services. And through a plugin API, what it does is it passes a Google Protobuffer message. And what that is it's a serialized message format that's automatically versioned. So it's basically like a pure old, or plain old data class, but it's able to be versioned so that you can make changes to the data class and it won't affect backwards compatibility of clients. So yeah, think XML on crack. That's really what GPB is. It's an open source library from Google that allows you to do serialized messaging. And once the community comes together and says, okay, I want this piece of information in my message packet that I receive from the kernel. Once you have those open debates, then people say, okay, well, I have these pieces of information that the kernel is passing me, and I can do whatever I want with that information. And then there's an API to give information back to the kernel. So the whole thing is try and standardize on these message classes instead of passing, for instance, a table pointer or a session pointer or a thud pointer in the MySQL world back and forth. That means that module developers have to be intimately familiar with how the actual core server works. We don't want people to have to know to spend 2 years going through the MySQL or Drizzle source code in the kernel just to do a module. We want you to be easily able to write a module just through the interfaces. So. Say no to crack. Magic. So magic, yeah. serializable. So they can be serialized, but they don't have to be. No. It's only a 20-minute presentation. I could go on and on about it. So, yeah. Trying to stick on time. Anyway, so saying no to magic code. There are so many areas in the actual code base where either through macro definitions or some weird pointer magic, things just happen. And when you have code that just works, but no one really understands why it works or how it works, well, that's an impediment to progress, because people will look at it and just get scared and start running away, fleeing, So what we've been trying to do is clean up that kind of magic code. Some of the magic code may have been in there for performance reasons, but a lot of it's like 10 or 12 years old. And some of the reasons that it might have been put into the code base for performance reasons, like, basically we know how to write memcopy better, so we're just gonna write it in macros, whatever. So we take the approach of, let's just use the standard library implementation, do the benchmarks. If we do see a difference, then we can use magic code, but it darn well better be documented as to what it's actually doing. Because we want more an active developer community, and you don't get an active developer community unless they can easily approach the code. So yeah, the bottom thing there is absolutely true. The amount of magic code in the code base is inversely proportional to the number of developers who can contribute to the code base. So our goal is to get that number up, so we want to reduce the amount of magic code. Cleaning up the code. So much mess, so little time. So any code base, it doesn't matter whether it's your application or MySQL or Postgres, everything develops cobwebs inside the code over time. It's just a natural thing. But what is good about the Drizzle project is we're trying to focus on cleaning up those cobwebs, cleaning them out, going in and refactoring the code. First of all, documenting where we can, where it's not documented, where no one really knows what's going on, documenting those things, pulling interfaces out in a more object-oriented way. So we're following standard C++ practices inside the kernel, and just making it easier for people to approach. But sometimes you do run into a few roadblocks. The following code actually is a little function called MySQL prepare create table. And there's also like a MySQL prepare create table too, and whatever. But anyway, so this is MySQL prepare create table. And I didn't change any of the indentation. There's a lot of code like this in there. And it wouldn't actually be so bad, but that's just half of it. And I took about 300 lines of code just to put it on two pages of the slides. But this is very unapproachable. Having this kind of code in there is exactly what we're trying to target. We're trying to clean it up, make the interface very well documented, and defined so lots of people can get involved and start, doing their own thing within the kernel and learning. It takes a long time to get through code like this. So we're trying to clean it up and make it approachable for people. And how does this have to do with performance? Anyone want to make a wild guess? Why do we actually want our service to be better performing, right? It's because it saves money, right? It saves money if you don't have to have, if you don't have to buy 100 servers, you can do it on 50 servers, right? That's why performance is good. Well, what's the greatest cost associated with software development? Programmer time. So if we can reduce the amount of time that it takes for someone to get involved and write features for Drizzle, then it's making better performing code. And I know you probably were thinking like, oh, well, is he going to talk about throughput and how I could do that? No, I'm actually talking about better performing code, because that's what I do now. I'm a code monkey all day long. But it's the greatest cost associated is programmer's time. And so if you can reduce the total time it takes for people to get involved, then you're making better performing code. So using standard libraries, it's related to magic in the code, enables code reuse, and it allows Drizzle people to focus on Drizzle stuff, not stuff that's tangential to Drizzle. We're happy to send library developers patches if we encounter bugs, but we're not happy to reinvent the wheel. We want to find open source libraries that meet our needs and don't reinvent something. Just non-invented here syndrome, we don't like that. So, the last thing specifically about how we address performance in the server is we don't look at raw performance, or we try not to. Sometimes we get concerned. Like recently we spent 3 weeks in chaos mode because of certain benchmarks. But what we're really focused on is scalability. Because the days of 16 concurrent connections, those are over. Sorry, but they are. Many major websites are running 1,000, 2,000, eBay, 10,000 concurrent client connections. If you're living in a world where you're benchmarking and looking at raw performance throughput at 16 concurrent connections, that's 3-4 years ago, 5 years ago. So you need to look past that and think of the scalability patterns. Once I move into 64 client concurrent connections, 1,024, 2,048, how is my scalability affected? How is my throughput affected? Do I do a big dive off the diving board and go flatline at 100 transactions per second, or do I keep a 2,000, 3,000 transactions per second? So if we can, what we're focusing on is removing those scalability problems. And we've removed a number of global mutexes that were a problem, and we've seen our scalability steadily increase. Global mutex is around, for instance, getting a random number, believe it or not. Global mutex is around show process lists that didn't need to be there. Global mutex is around things like temp pool, which just basically created a new temporary table name, a different way of creating a temporary table name. So just little things like that. Just identifying those contention points that are on a global level. Anything on a global level that's a contention point, that's a mutex, we try and remove that or address it with different strategies, whether it's atomics or read, copy, update, or other strategies like that. So I'm almost at the end here. So the soundbite, more contributions. So we focus on the APIs, clean code, standard libraries, open and public discourse is the #1 thing. Easier to contribute. We're friendly. Cleaner, more standardized code base, fully public, peer code reviews, and they're friendly, right, Patrick? Right, Tori? See, we're all friendly. And then scalability over raw performance. If we have raw performance slowdowns at the lower concurrency end, but yet we scale gracefully up to very, very large, very, very high concurrent connections, that makes us happy. So anyway, we think this will lead to more eyes capable of discussing and debating and dissecting the code, and that's a good thing. So please join us. Thank you.